In this problem, they're giving us two bodies P and Q on a perfectly smooth horizontal surface area connected by a light cord. They're also giving us the data that the mass of P is greater than the mass of Q. Moreover, a horizontal force of F is applied to Q, as shown in the picture. So a couple things to know before we start. The force is gonna go this way to the right. Therefore, we can say that the sum of the forces going to the right equals mass times acceleration. But we could also write little m as m capital plus m little, given that P is m capital and Q is m little. Then we just multiply by the acceleration, and we can rewrite the equation to give a value for acceleration equals F divided by m capital plus m lowercase. Now, since we know that big M has a greater mass than little m, we can also say that little m is less than big M. So we can conclude that little m divided by big M is going to be less than 1. Say we give a value for little m 1 and big M 2, it's going to be 1/2. It's going to be around 0.5, which is less than 1, just for an example. Then as we continue, we have a value of A that we found right here. So we could just plug it in right here. And then, so to simplify the fraction, we could say, we could divide both the numerator and denominator by m, capital M. And therefore, doing some algebra, we end up with this F over 1 plus little m divided by bigger M. Same thing as we saw up here. F divided by 1 plus m divided by bigger M is going to be less than the force of M. But we have to remember that F of M refers to the mass of P, because that's what the original question says. So the force of M is going to be equal to the force of P, which is going to be equal to the external force divided by 1 plus little m divided by big M. Ever since we said that m divided by m is going to be less than 1, we could say that it's going to be close to 0. Therefore, we just plug in the value right here, and we end up with F over 1. Therefore, we can conclude that the force of M, in this case the force of P, is going to be less than the force right here, which is highlighted in this area. And that's the final answer.